Hi, this video is going to be a quick example of making a confidence interval for one proportion using the normal distribution. And specifically, I want to show you how you can use the calculator to do this without rounding. Because when you do round along the way, when you're calculating confidence intervals or test statistics, what often happens is you will end up outside the range of the tolerance for Wiley Plus. And when that happens, you really don't have any way of knowing very easily whether you're misunderstanding the material or if you are simply having rounding errors. So it's very important when you're working in Wiley Plus not to round along the way. And I want to show you how you can use the store function in with the Texas Instruments calculator to avoid rounding along the way. Okay. So we are going to estimate the proportion of all UVM undergrads who spent the summer in Vermont. We had a random sample of 125 UVM undergrads, of which 44 spent the summer in Vermont, and we want to find a 90% confidence interval for the true proportion of all UVM students who spent the summer in Vermont. Now our sample estimate, which we call P hat, our sample proportion, is going to be 44 out of 125. And we're going to use that to calculate our confidence interval. Our confidence interval is going to take the form P hat plus to get the upper limit of the confidence interval and minus when we get the lower limit of the confidence interval. A critical value, Z star, that's going to give us the level of confidence that we're looking for, here 90%. We're going to get that from StatKey, times the standard error, which we are going to estimate with P hat times 1 minus P hat divided by n, and we take the square root of that whole quantity. Okay, so first of all, let's see how we can get our Z star. If we're in StatKey, we need to go into the theoretical normal distribution, which is where I am now. Now, when you first come in here, and if you click on the two tail, which is what we need, it will give you 95% in the middle, and it will give you these cutoff values. Those are the cutoff values if we want a 95% confidence interval. But if we want a 90% confidence interval, we need to change this number that's in the middle to 90%, 0.90. We hit OK, and we can see down here it gives us a new cutoff value. This is the Z star for a 90% confidence interval, 1.645. So we're going to use that for our Z star. Okay, so there's our Z star. So now our confidence interval is going to look like this. It's going to be my P hat plus and minus 1.645 times the square root of P hat times 1 minus P hat divided by our sample size, 125. Now, I can calculate my P hat. Let's get my calculator out. So if I calculate my P hat, 44 over 125, 44 divided by 125 is 0.352. Instead of typing that all in every time, I am going to store that number. And this is especially important if you have something with lots and lots of decimal places and you don't want to be rounding it. You're going to want to store the value of P hat. So the way that you do that is you use this button here. It's called the Store button. It takes the answer and puts it into a particular place. Now we can use the X button. So I just press this X key, say the N button, press it once and it'll give you X. So now what it'll do is it will store the number 0.352, which is our p hat, in X. So now if I type in X, which I do by using the alphanumeric key, you can see here we've got the X. So I do alpha X, and you can see that it's assigning that number every time I type in X. So now if I want to calculate my confidence interval, I can put that number in directly. So I can do the lower limit of my confidence interval, and take my p hat minus this quantity. So I've got my X value minus my z star, 1.645 times, I need a square root, it's the second command here. Now I'm going to use my p hat, which I stored in X, remember. So I do alpha and my X times. I'm going to use the parentheses around my 1 minus p hat. Parentheses, 1 minus p hat is in X. And then divide by my sample size, 125. And it gives me the lower limit of my confidence interval. .2817. I'll round at this point because I'm on my final answer. Now I can do the same thing to get the upper limit. I'm going to start with my p hat, which is stored in X. Alpha X. This time I'm going to add plus my z star, 1.645 times, I have my square root, second. Now I need my p hat again, that's stored in X. Alpha X times 1 minus p hat, that's in X. Close those parentheses and divide by 125. Then I've got one more parentheses to close. And I get 0.42226. So we'll call that, if I round to 4 decimal places, 0.4223. So I can be 90% confident that the true proportion of all UVM students who spent the summer in Vermont is between 0.2817 and 0.4223. I hope this is helpful. If you find that you have questions, please don't hesitate to ask. As I say, it is extremely important not to round your answers along the way when you're calculating these confidence intervals and also the test statistics. So if you're finding that you're having trouble, please let me know and I'll make an additional video. Thanks.